Hi, welcome to LeetCode. So in this video, I am going to discuss LeetCode problem 3508. Implement router. So the problem statement is that design a data structure that can efficiently manage data packets in a network router. Each data packet consists of the following attributes. So what are the attributes? First attribute is source, a unique identifier for the machine that generated the packet. Then destination, the unique identifier for the target machine. Then another is the timestamp. So when actually this packet actually created or arrived at the router. Okay. Now this is we have to implement what? First we have to implement a class router. First is the constructor, router constructor. I will get one parameter, that is memory limit. It initializes the router object with a fixed memory limit. Okay. In the letter, memory limit is the maximum number of packets the router can store at a given time. So suppose our this is mean the capacity of the router. So this many number of packets can be present in the router at any time, maximum. Now next is, if adding a new packet would exceed this limit, the oldest packet must be removed to free up space. Suppose our maximum capacity is suppose 10, and I already have 10 packets in the router. Now next 11th time when I am trying to add any packet or trying to store any packet in the current router, then what you have to do? First you have to remove the old. Old means the whatever actually the packet actually created or arrived at the first or the oldest time. So that we have to remove first. Then we will store this new, the 11th packet in the router. Okay. Next function is that will add packet. So it will get three parameter. One is the source, then destination, and the timestamp. So this function, what it will do? It will actually store the add a packet with the given attributes to the router. That means we have to store this current. This is the complete packet. So in one packet actually have three attributes: source, destination, and timestamp. We are getting three things: source, destination, and the timestamp. So we'll create a new packet, and before storing this new packet, we have to check that this is actually exceeding the capacity or not, maximum capacity. If it is already reach the maximum capacity, then what I have to do? Remove the oldest packet from the router, and then we will store this new packet. So a packet is considered duplicate if another packet with the same source, destination, and timestamp already exists in the router. So there are two possible. So in this function add packet, two things is possible. One thing is possible, that duplicate. We have to handle duplicate. So if this is to duplicate, then we have to return a packet is considered duplicate if another packet with the same source, destination, and timestamp already exists in the router. So then we have to return false. Else return true if the packet is successfully added. It is not a duplicate. Otherwise return false. Successfully added means, so before adding, so first of all I have to check that this is actually duplicate or not. So one situation is possible. Then another situation is possible, that reached maximum capacity or not, right? We have to check that after checking the duplicacy. So if it is not duplicate, then we check that we have already reached the maximum capacity or not. If I have already reached the maximum capacity, then remove oldest packet, right? This is clear. Then we will add this new packet into the router and then return true. Correct? Here return is false if it is already duplicate, and after adding this we have to return true. So two situations are possible. Next is another member function is present, that is actually forward packet. So what is forward packet? So here the syntax is that we have to return something vector list array, integer array. So forwards the next packets in FIFO, first in first out order. Remove the packet from the storage. Okay, so this is forward packet. So what we have to do, we will remove the oldest, means whatever first in first out, FIFO means whatever actually the packet actually arrives first, that will be forwarded first, correct? So this will remove oldest packet removed, correct? Now what I have to do, remove the packet from the storage. Then what I have to statement is that return the packet as an array. Okay, so I have to return this packet. This packet means the source, the destination, and the source, destination, and the timestamp when actually this packet actually arrived in the router. Next is we have to return this. If there is no packet, there are no packets to forward, return an empty. So we have to check that is there any packet or not, correct? So if there is no packet, we have to return empty array. Got it? Now next function is getCount. So what it will do, it will take three arguments. One is destination, another is start time, and end time. So returns the number of packets currently stored in the router, not yet forwarded. Okay, forwarded means we will remove from our router. That means it will not present in the router currently if I have already forwarded that packet. So we will return the number of packets currently stored in the router that have a specified destination and have timestamps in the inclusive range, start time and end time. Okay, so this get count will return how many packets or destination is the whatever actually we are getting from the argument, input argument, and the timestamp is in between. Suppose we got actually left and right, so the timestamp will be greater than equals to left and less than equal to right in this range, correct? So now we have to count that, correct? So, and another thing they mention in the note that queries for add packet will be made in the increasing order of timestamp. So add packets will actually get new packet. So this is actually sure that we will get the increasing order, correct? Duplicate is possible, but not like that. First we timestamp we are getting something 10 hours, then we are getting 9 hours, 9 o'clock, 10 o'clock, then we are getting a packet that is created at 9 o'clock. That is not possible. Got it? So this will help us in solve this in efficiently. Let's see how. So I think they mentioned that, that's why. So one thing we need to do that, we will check that duplicate or not, correct? Another is that we will check that is there any packet or not. Why? Because if there is no packet, we have to return an empty array. Or actually empty array? Empty array means this function will forward packet. If there is no packet, then we have to return an empty array. Otherwise, we have to return the source, destination, and the timestamp, whatever the oldest packet is present. So these things we need. Another is we need that for particular destination, we should know that which or how many packets is present, correct? So for duplicacy, what actually we can do, we can use a set, correct? Set will help us here, that particular, because whatever is the repeated case, like what does set do? Suppose set we have inserted 1, then again if we try to insert 1 again, then it will say that okay, this 1 is present or not. We can actually easily find out that, right? So that's why for this duplicacy I will use a set, or actually I will whatever the data it will store, it will store the source, destination, and the time. So I'll check that is there any matching data that actually is similar, right? Source, destination, time. So this is for duplicacy handling. Now I have to check that is there any packet or not currently. So what actually we can do? So we need actually one list of packet, any list of packet Correct, list of packet. Next we need actually for this point 3, for any destination we need to find out that how many actually packets is present. Then actually we can easily find out that we can easily big off by using, if we know that for this particular destination, these are the list of packet, suppose. Then we can actually check that we know that the left and right of our timestamp, the range. So I will iterate this list. Then actually easily you can actually check that count. We need only the count, that how many actually the packet is present within this range, left and right. So what I'll do, I'll iterate this list, because I know that this list is for particular this destination, right? So I'll check that whatever the timestamp actually this packet actually have, this actually within this range or not. If it is within this range, I will actually count, increase the count. Correct. So this will actually take big of n. Okay, first of all we need to actually map our destination will be the key and the list of packet for this particular destination. So for this it will take big of 1. So now we will get a one list of packet. So this will take big of n, because I am iterating each packet. Then we'll check that this packet actually within this range or not, within this timestamp or not. So this will take big of n ultimately. So but there actually they mention that this will be big of list size can be 10 to the power 9. Correct. Okay, memory limit is 10 to the 5. So our array size will be at most 10 to the 5. So this will actually take 10 to the 5 to iterate the whole array. What are the list actually packet actually I have for this particular destination. But if I call this 10 to the 5 times, it will take actually 10 to the power 10. So this will give actually TLE. This is clear. If our array size is, this is for array size for particular destination. So I'm iterating each packet and I'll check that this actually within this timestamp or not. Then actually will increase the count, else I will go to the next packet. And this method can be called 10 to the 5 times. They mention that at most 10 to the 5 calls will be made to add packet, forward packet and get count. So this, suppose this method can be called 10 to the 5 times, this get count. So that time for each time it will take 10 to the 5. So if I call this 10 to the 5 times, it will take 10 to the 5 into 10 to the 5. Got it? So that's a 10 to the power 10. So can I actually optimize this? Yes. How? They mention that our packet is actually timestamp actually is increasing order. Correct? Increasing order. So I know that our packet will be actually coming in increasing order. Timestamp will be always increasing. So I can use the binary search here, because this is already sorted. I know that what is the left and what is the right. So if I use the binary search, that what is the index, starting index, or starting from this left timestamp, the starting timestamp, and if I know that what is the index for the rightmost index of the this ending timestamp, this rightmost timestamp. So I know the left index and the right index by using binary search easily. Now what I'll do, I'll check that how many actually number actually present within this index. So this is actually something idx2 minus idx1 plus 1. Correct? R minus L plus 1. This is the number actually present within this index, within this range. Got it? So if I use the binary search here, so it will take actually log n, and it can call it to 10 to the 5 times maximum. So this will be 10 to the 5 into an array size can be 10 to the 5. So this will be 10 to the 5. Got it? 5 into 10 to the 5. Got it? How actually optimize this? So this will actually work. So let's recall the steps again. To check the duplicate or not, I will take a set of packet. Okay, this is for duplicate or not. Next, what actually I need? I need that because list of packet while list of packet, this actually check that is there any packet or not, correct? So what actually it will help us, this data structure, it will help us here in this case a forward packet, correct? Because ultimately you're storing in any order. In forward packet, we don't need that what is the destination, what is the source. Ultimately, whatever actually the oldest packet is present, that will be actually removed, correct? So that's why I need this sorted order, like actual order. This is actually stored the actual order. So list of packet, is there any packet or not? So this actually help us duplicate set. This actually help us in which case, in which function, add packet, correct? This will help us here in this add packet. This will help us in the forward packet, correct? And next we are talking about that map, that actually help us for particular destination, how many packets are present within this range left and right. So I'll take one map of particular destination of list of packet, and I know that this will actually sorted, this list of packets, because they mentioned that the packets timestamp will be always increasing order, correct? So for particular distance I will check that is there any entry on this map or not. So this function, this data structure will help us in this getCount function. This is clear how actually analyze the problem statement, then how actually we actually find out that which data structure help us in which case, what actually condition actually I need to handle, got it? So I think this will help us in future also, because similarly there are some questions actually coming in this LeetCode recently related to this simulation type. We have to design the data class, and we have to design the function also, implement the function also. But so this is clear. And another also, we need to also the maximum capacity. This is also called, we will get from this constructor, maximum capacity of the router. So first of all, we need to check that the duplicate or not. Whenever actually calling any add packet, if it is not duplicate, then we will return from there. And if it is not duplicate, then we'll check that we actually reached the maximum capacity or not. If it is already reached the maximum capacity, then what have to do? Remove the oldest packet. So when actually get the what is the oldest packet, I'll get from here, list of packet. This will store the ultimate actual or original order of packets, correct? So whatever actually, so it will actually, what is the data structure we should use here? We can use actually queue here, because first in first out. So what is the oldest packet, that will be present in the front of the queue. So I will pop that and I will adjust that. What actually to adjust before removing from the queue? I will adjust that we have to remove entry from the destination also, destination map, correct? Any other thing? Duplicate, okay. I have to also remove from the duplicate also, because this entry is not present now in the router. So that I have to handle before removing any. So before removing any packet, what I have to handle? First, adjust the duplicate, because this entry is not present, so I will remove from this duplicate set. Next, I have to adjust in the destination map also, right? It's storing that for particular destination which actually packet are present. That we have to adjust that also. Correct. So this is for when removing any packet. Now, when you're inserting any packet, when you're going to insert any packet, then what have to adjust? Similar way, we have to handle the duplicate, because in future if we get any same entry, then we have to handle, we have to return that this is already present duplicate entry, so that we have to adjust. So duplicate set also we have to handle that. And also it may possible that after add packet, we can actually call getCount. Then also we should know this particular destination, this packet is present or not within this time stamp, so we have to adjust the destination map also. Correct? This is clear. So before removing also, and before adding this new packet, we have to adjust these two things. One is for duplicate, another for destination map. Okay, and list will be always a list that in the queue ultimate order of the original packets, that will be always stored in the order whatever we are adding new packet. So now go to the code. So I think this is clear. If any doubt, any suggestion, you should comment on that. And if you're not yet subscribed, please subscribe the channel. Now go to the code. So I'll get one maximum capacity of our current router. So in constructor I'll get that memory limit. So I will actually initialize this value with maximum size of the whatever the value you're getting memory limit in the constructor during initialization. Now one thing what actually I need, which actually packets I have seen. So that's why I need to run set to check to handle the duplicacy, right? So it is a set of vector of integer what is to store the packets. So they mention the honest duplicate, we have to match exact things, means source, destination, timestamp, all these three should be matched. So that's why we have taken vector of integer. I'll show three things: source, destination, and timestamps. Correct? And this is queue. This will store the actual order of the packets currently present in the router. So this will help us when it will remove forward packet. So to remove the oldest packet first. So this will be present at the front of the queue. So I'll remove from that in the queue, from this queue. And another map is needed. So this map actually store what? This for particular destination, which actually how many actually the packets is present. This will actually help us in the getCount function, right? So I'm calling this function, first implementing this function add packet. So I will get actually three things: source, destination, and timestamp. So first of all, I will create a packet of this three value. First, what would check before adding that? Now you can see that before adding that, we have to check that duplicate or not. A packet is considered a duplicate if another packet with the same source, destination, timestamp. So how actually check that? I'll check that this from this set packets. I'll check that this actually present or not. If packets dot count, we pass the current packet. If it is non-zero, that means this is already present. So return from false. So they mention that if it is duplicate, otherwise return false. So if it is duplicate, return false. Else what I have to do? I will store this, means this is not duplicate. So I'll store this into the router, current router. So what I'll do? First we'll check that we have already reached the limit or not, maximum limit, maximum capacity. So how is it check? How many actually packets is present in the current router? So how it will check that? In the queue size, queue it will store all the packets in the order also, original order. So I'll check that if the queue size is equal to the maximum limit, maximum capacity, so that means we have already reached the maximum capacity. So what I have to do? I'll remove the oldest packet from the queue or from the router. So I will actually get the what is the front packet is present. Packet is present at the front. So I'll pop from the queue. Now this is not present in the router now. But what I have to do? We have to also adjust the entry also. Or actually entry is present. One is present in the set of the to handle the duplicacy. Another is in the map, or actually storing the particular destination. This actually the packet is present. So this is not present now. It has been removed from the router. So now I will just erase this current temp, means the oldest packet from the packets, right? Correct, this set from this duplication, that this actually this I have not seen this current packet, this oldest packet now, because this has been removed. Next also I'm handling this pop front. Why should we are using the pop front here? Because I know that this will be removed. This actually increasing order, timestamp is already sorted in increasing order. this actually mention that. So I know that the oldest will be always removed, oldest will be stored first in the will also come first, so this will be also removed first. So that's why I know that this will be always stored in the front. So that's why I'm just removing from the front in the destination also, destination map. Correct? Now it may possible that only one entry is present, only one packet was present in this particular destination. It may be possible. So what will do, I will also delete this particular entry also, particular destination entry also. Correct? So that's why I also delete this. If we'll check that for particular destination, after removing this current packet, okay, if there is no packet now for this particular destination, so I'll remove the entry for the current destination also, this destination. So I'm erasing this destination by the timestamp dot erase the current destination of the oldest packet. Got it? Now after this if block, we actually we have make sure that there is at least one space in the router. Correct? If there is already a space, then we will not enter this if block. Else if there is we have reached the maximum capacity, then we have removed the oldest packet, and also handle the side effect also in the packets, in the duplicacy, to handle duplicacy and the destination map. Correct? Now what I'll do, I'll just insert this new packet. So I'll just insert it in the queue, the current packet, and also we have to handle this other thing also. Before adding new packet also, I will share these two things. Before reviewing also, we have to adjust this duplicacy set and also the destination map, and also during the insertion of a new packet, we also handle these two things. So similar way I'm handling this. So I'm inserting the current new packet into the packet set, because I have seen this current packet. So next, also I have to particular this destination. I know the packet 1 is storing the destination packet 1. This is source, will present at index 0, destination is present at index 1, and timestamp is storing at the index 2. So particular this destination packet 1, it will store the actual destination, and I will push back and the current timestamp, this timestamp, and storing at the index 2. Got it? This is storing in the sorted order. So that's why we can actually, in the get count, we can call the binary search here, use the binary search logic here. Correct? And also how it's using the, because they mentioned that this is actually sorted order, increasing order, timestamp. Correct? And ultimately return true. After successful insertion, we have to return true. Correct? So this is still clear. Add packet. Now next is forward packet. Forward packet, what to do? We will check that is there any packet is present or not. So how to check? We'll get from the queue, this queue. This is actually ultimate store all the packets in the original order. So I'll check that if queue is empty, if our queue is empty, there is no packet, so return an empty packet. Correct? Empty array, vector of integer. Else what to do? I have to remove the oldest, whatever actually the packet is present at the front, we have to remove that. So whatever the packet is present front, I will first store this in the temporary variable packet, and also pop this from the queue. Got it? Now before removing this, I have to also adjust the two things. One is for the set, or it's storing the entry of the particular packet to see that this is a duplicate or not, and also for the destination. So similarly, first I will remove from the set packets dot erase the current packet, whatever we removed or we have forwarded. Okay. Next, we have to similar way, before removing we have to check that this particular destination, I know that whatever you forward, that will be always the oldest. So I will pop from the front of the queue of the particular destination. I know destination, what are the packet actually we have forwarded, we know the destination, and we will pop from the front the timestamp. Now if this particular destination is only, there is no packet is now present in this particular destination, so what I do, I also delete the destination also, entry for the destination. So I'll erase from this particular destination. Got it? And return the packet ultimately. Got it? Now this is clear, forward packet. Now this is another function, this is actually get count. What actually we have to return, that how many actually packets are present within this timestamp, left or right inclusive, and for particular destination, for this particular destination how many packets is present. So source can be different, there is no matter. So I'll check that this destination is actually present or not in our map. So if there is no entry, that means there is no packet for this current destination, so I'll return 0. So I'll first check that For destination versus timestamp, find the particular destination. If it is end means there is no entry, so return 0, right? And if there is entry, there is some entry in the map, that means we have some packets for this particular destination. Now we have to check out how many actually packets are present within this range, left and right. So I can use the binary search here, but instead of the customize function, I have used here actually lower bound and upper bound. So lower bound, we know that it is return the pointer of the starting index, or actually this value is matched, or just greater than this, greater than equals to the current value, or actually what you are trying to search. So this is a start time. We know that this is a left value. So I'm starting from this particular begin to end. The search space is the begin to end. I'll start for lower bound. I'll check that which is the index actually it's matched the start time. Okay, so I'll store this in the left. And similarly for right actually this upper bound actually store return what, the greater than whatever the value we're trying to search, end time, greater than the value end time. So suppose this actually the 1 2 3 4, okay, 5, and left is what you're trying to search, suppose 2, and right we are trying to search suppose 4. So what is the inclusive range? They mentioned that 2 and 4 is the inclusive, the timestamp is inclusive timestamp. So ultimately what is the range? Actually I will actually valid range 2 3 4. So lower bound will return, what are the value actually we are trying to search, left greater than equals to the index or index value greater than equals to whatever trying to search, left. So it will actually return this point, index pointer of this particular 2. Got it? And right upper bound return what? If I do upper bound of 4, then return the index that is greater than 5. Greater than 5, it will return 5, not greater than equals to. In lower bound, we actually return greater than equals to. But for upper bound, we sure that this is greater than the value we are trying to search. So I'll get 2 pointer, one is pointing here, another is pointing here. So how many actually elements are present? If you directly subtract this position, so this actually position is 0 1 2 3 4. So if I right is pointing at 4 and left is pointing at 1, we can easily do 4 minus 1. Got it? So 3 actually elements are present. You can see that 2 3 4. Got it? So that's why I've taken two things. One is lower bound for searching the start time, that is greater than equals to the start time, and upper bound to get the greater than the end time. So just after that we return right minus left. Got it? This is clear. So I've shared this code in the description, you can check that. And thank you. And if you're not subscribed, please subscribe the channel. Thank you.